Ignition sequence start.
Good morning, and welcome to a look inside the International Space Station Flight Control Room at NASA's Johnson Space Center in Houston. This is where a team of specialists is always on duty, keeping an eye on space station systems and assisting the Expedition 66 crew members with their work of science research and station maintenance. Commander Thomas Pesquet and his crewmates have reconfigured from a visit by a Russian actress and film director and have turned their attention to a new crop of scientific experiments while monitoring activity with Russian cargo ships.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Nilofer Ramji. A return to Earth and something spicy. Here's what happened this week aboard the International Space Station.
Touchdown confirmed.
During the early morning hours on October 17th, Russian cosmonaut Oleg Novitsky, along with Russian actress Yulia Peresild and producer Klim Shipenko, returned to Earth on their Soyuz MS-18 spacecraft. This was Novitsky's third mission that spanned over 3,000 orbits of Earth, covering over 80 million miles. Spacecraft participants Peresild and Shipenko returned to Earth with 12 days in space, during which they filmed portions of an upcoming movie titled Challenge. Research into growing plants in space continues with a spicy twist. As we prepare for long-duration missions further from Earth, it will be important for astronauts to grow their own food. Currently aboard the International Space Station, crew members are seeing the fruits of their labors in the advanced plant habitat, where chili peppers are emerging. Peppers are a good source of vitamin C, which will be an important dietary supplement for the long-duration missions in the future. NASA astronaut Megan MacArthur tweeted that the crew was just a few weeks away from harvesting and eating the first peppers in space, so stay tuned. The space station crew is preparing for the arrival of a Russian cargo ship. The Progress 79 resupply craft is scheduled to launch on October 27th from the Baikonur Cosmodrome in Kazakhstan. The launch of this Progress follows the relocation of the Progress 78 cargo craft currently on station from the Poisk module to the Noka module. NASA TV will provide live coverage of the launch on NASA TV, the agency's website, and the NASA app.
Space to Ground.
Last week, we reported that 3 CubeSats developed by students were shot into space. We wanted to make a correction that it was the University of Massachusetts and not the University of Michigan that developed one of the CubeSats that was deployed from the space station. Our apologies for the error. That's Space to Ground for this week. Thanks so much for watching. We'll see you next week.
The research goals of the International Space Station include traditional kinds of laboratory science experiments and a number of technology projects that are intended to find ways to make future space exploration simpler and more efficient. And that includes a current experiment from NASA's Ames Research Center exploring the use of free-flying robots that could serve as assistants to human astronauts. The laboratories of the International Space Station aren't the only places on the vehicle where scientific research takes place. The outside of the station is home to a number of experiments, including the Total and Spectral Solar Irradiance Sensor, which is continuing NASA's work of gathering data to help researchers investigating changes to Earth's climate.
Follow the sun. Presented by Science at NASA. The sun. It inspires songs, warms us, and grows our food. Life on land and in the oceans, the daily weather, and long-term climate patterns happen primarily because of the energy we receive from our closest star. Even tiny variations in that energy can affect the workings of our planet's atmosphere. NASA uses instruments to follow the sun and monitor the amount of solar energy coming to us. The latest instrument to do so, the Total and Spectral Solar Irradiance Sensor, TSIS-1, makes those measurements with unprecedented accuracy. TSIS gathers information from its perch aboard the International Space Station, or the ISS. Flying on the platform that the orbiting laboratory provides has allowed TSIS to continue NASA's 40-year record of tracking the sun's radiant energy, one of the longest and most important climate data records gathered from space. Over the past several decades, Earth's ice mass has diminished, sea levels have risen, drought and precipitation patterns have changed, and growing seasons have shifted. To understand the causes, including human influences, of these changes, and to refine the models used to simulate Earth's climate, researchers must know the amount of incoming solar energy. Peter Paluski, TSIS lead mission scientist, explains, when there's a balance between incoming energy from the sun and the infrared radiation Earth emits, climate remains steady. An imbalance means energy is either being stored in the system, causing temperature increases, or lost, causing temperature decreases. Energy from the sun makes up half of the balance equation. Even though the measurement record shows that the sun's solar energy output has not had a major influence in recent climate change, that output needs to be monitored continuously. It is arguably the most important variable we need to know to understand climate, says Paluski. Trying to understand climate without measuring the sun's input is like trying to balance your checkbook without knowing your income. Climate is measured over long time spans, decades to centuries and longer, unlike weather that changes over small time scales. To be able to connect measurements over long time periods, continuity and accuracy are key. TSIS has two sensors. The Total Irradiance Monitor, as its name suggests, measures all of the radiant energy from the sun, and the Spectral Irradiance Monitor measures how that energy is distributed over ultraviolet, visible, and infrared wavelengths. The latter helps scientists understand where in the atmosphere solar energy is being absorbed. For example, TSIS spectral irradiance measurements of the sun's ultraviolet radiation are critical to understanding the ozone layer. Ozone in the stratosphere absorbs ultraviolet light. This heats the stratosphere and drives changes in atmospheric wind flow that can propagate down to the lower atmosphere and impact climate. So many factors influence Earth's climate, says Paluski. We need to continue learning how they all interact. TSIS is helping us characterize the sun's behavior and how Earth's atmosphere responds to the sun. For more science from the International Space Station, go to www.nasa.gov/ISS-science. To continue following our closest star, visit science.nasa.gov.
The International Space Station is a state-of-the-art microgravity laboratory that is unlocking discoveries that are not possible on Earth and helping push us farther out into deep space. Well, not only that, the work that is being done on a platform that is the largest international collaboration of our time is also serving to inspire future generations.
The International Space Station is a state-of-the-art microgravity laboratory that is unlocking discoveries not possible on Earth and helping us push farther into deep space.
Every single day, we are answering big questions about Earth and about space, about where we came from and about where we're going. But the other thing that we're doing is we're learning more questions to ask.
Microgravity turns almost everything we know upside down. Liquids behave completely differently. Fire burns in new ways. Biological systems reveal surprises.
There's a few things that have made me gasp out loud up on board the space station. Watching heart cells actually beat has been a pretty big one.
We're studying ways to grow food in microgravity.
I got to tell you, these are pretty amazing.
We're learning how human bodies react to life in space and how to keep crew members safe and strong on long-duration exploration missions.
Deadlifts are awesome on Earth. They're also awesome in zero gravity.
We're testing technologies that will be critical to our return to the moon and great leap to Mars. Our research has contributed to medical and social benefits on our home planet, allowing us to find new ways to combat disease back on Earth and develop technologies to deliver clean water to remote communities in need. The spectacular vantage point of more than 200 miles above our planet supports our monitoring of Earth's climate, natural disasters, and plant life.
I can't begin to describe some of the sights that you get to see. It's just an incredible view of our planet that we have from here.
The growing new space economy, so vital to our continued progress in space, is flourishing in low Earth orbit. We're inspiring future generations from a platform that is one of the largest international collaborations of our time. We're doing science at 17,500 miles per hour. Come along for the ride.
One major goal of the International Space Station is to help us learn what we need to know to support future space exploration, such as working out the systems of new spaceships to support the human needs of the astronauts on long journeys to deep space. That would include systems to provide clean water. In this installment of the Demonstrations video series, astronaut Drew Feustel discusses the water recovery system used to recycle crew wastewater for consumption.
Hi, I'm NASA astronaut Drew Feustel. Welcome to the International Space Station. On our station, our water recovery system is vital to our mission and our survival. Want to know why and how we recycle and filter our water? Let's go. We use water recovery and filtration because it is expensive to launch resupply missions, and the weight of the water is a problem as well. Think about the weight of a single bucket of water. Can you imagine the weight of water for a month's supply for 6 people on the International Space Station? What about the water for a year or more when we leave low Earth orbit for deeper space missions? That's a lot of water, and bringing it with us is not very efficient. On station, we recycle wastewater to get fresh drinking water. This recovery and filtration process includes our urine, moisture we exhale, and sweat, along with the water we use to bathe and shave. It works like this. When we use the bathroom, urine is collected and pumped to a distillation assembly. The assembly spins, pulling the urine to its walls. The urine is heated to evaporate water from the waste and then condensed in the outer chamber to form distillate. Next, the water is pumped to a tank where it is joined with the water recovered from cabin air created by crew sweat and respiration. Down the line from there, odors and any other contaminants are removed with heat. Then iodine is added for microbial control. Our water is checked often to ensure it meets water quality requirements. It is also monitored closely for bacteria, pollutants, and proper pH. The pH scale ranges from 0 to 14 and is a tool used by scientists to measure the strength of an acid or base. Our water is required to be in the 6.0 to 8.5 range. The end result of the entire process is clean drinking water that we get to enjoy every day. The recycled water on the space station is sterile. There's no odor or bad taste. You've seen that water recycling is critical for long-duration missions, such as here on the space station, and will be for future trips to the moon or Mars. Be sure to check out the activity connected to this video so you can learn more about water filtration. Thanks for learning with me, and I'll see you next time.
Preparing the hardware for voyages out into space is only a part of the International Space Station's mission of preparing for NASA's future flights of exploration. Scientists are using the station to find ways to protect human explorers from the negative effects of being in weightlessness and from the conditions they'll encounter on long trips to deep space, including the galactic cosmic radiation that comes from supernovas.
One of our biggest challenges on a mission to Mars is protecting the crew from radiation. You can't see it, you can't feel it, you don't know that you're getting bombarded by radiation, but we do have operational dosimetry and crew personal dosimeters that we can measure it.
Space radiation comes from three major sources. One is there are radiation particles trapped around the Earth, and they're called the Van Allen radiation belts. The second source of radiation is from the sun. During times of intense solar activity, there can be solar storms and high fluxes of radiation. Protons in particular can reach Earth. The third source of radiation in space is called galactic cosmic radiation, and that's the one that's of most concern for a mission to Mars. The galactic cosmic rays come from exploding stars that we call supernovas.
So I think one of the common misconceptions about space radiation is just how different it is from the type of radiation we have here on Earth. So here on Earth, when you think about sitting down in a dentist chair, they put some kind of lead blanket on your chest to protect you against X-rays. In space, it actually is very different. We don't want heavy materials because it makes the exposure worse. We want things like hydrogen, things like water and polyethylene. The primary reason for that is in space we have particle radiation instead of electromagnetic radiation. Particle irradiation is basically everything on the periodic table, hydrogen all the way up through nickel and uranium, but moving at speeds that are close to the speed of light. So thinking about the differences between Earth-based radiation and space radiation, we have a long history and a decent amount of data about the biological consequences of exposure to terrestrial radiation. Where we lack data and we have a large amount of uncertainty is the biological consequences of space radiation. And so really the next steps are, and the ongoing steps are to try to understand those exposures better and the biological consequences that follow them.
Studying the space environment is just a part of the effort for future space exploration. NASA's Artemis program is also developing the hardware that will be needed to return astronauts to the Moon in just a few years and then take them out into deep space. Here's a breakdown of the elements that will support NASA's plans for moving us out beyond low Earth orbit.
So you want to go to Mars. How do we send humans to deep space? In order for humans to explore the Moon, Mars, and beyond, we need safe, flexible, and powerful systems that will make it all possible. We start with the world's largest spaceport. At Kennedy Space Center, we have all the buildings and tools needed to assemble and launch space vehicles, and have the teams in place to recover the astronauts when they come home to Earth. Next up, we need a deep space rocket. This is NASA's Space Launch System. It will be the most powerful rocket NASA has ever built, and it has the muscle to lift people and all of the equipment needed for missions to new worlds. The Space Launch System will blast off with the crew in the Orion spacecraft. The most advanced spacecraft ever built for human exploration, Orion provides the life support, power, communications, and other systems to safely transport astronauts on a variety of exploration missions, like to the Moon. In lunar orbit, we will learn to live and work in a deep space environment, something we have never done before. In future missions, NASA's Gateway will be a place for astronauts to live, work, and prepare for missions deeper into the solar system. There you have it. NASA's Deep Space Exploration Systems, charting our new future in space. To find out more about deep space exploration, visit this NASA website.
Astronauts on the International Space Station today eat the same kinds of foods as people on Earth, but they prepare them differently. During his first long-duration flight, astronaut Shane Kimbrough demonstrated the on-orbit preparation of one of Earth's most popular foods, the humble peanut butter and jelly sandwich. Although in this case it's made without bread and without the benefit of being a juggler.
Hello everyone, I'm going to show you how to make a peanut butter and jelly sandwich from the International Space Station. Every time we eat, it's kind of fun. Everything will float around if you don't manage it. So we have some tape to stick things on our table here, as well as a bunch of Velcro. All right, so the first thing we need for our sandwich is a piece of bread. Well, up here we don't have bread like you do on Earth, but we have tortillas. So we use tortillas a lot for sandwiches. So that's what I'm going to use for my peanut butter and jelly. I'm going to stick that down to some tape here so it doesn't go floating away while I'm getting everything else ready. So I'll get my peanut butter out, and even the lids on the peanut butter have a piece of Velcro on it so they don't go floating away. If I let it go, it'll kind of just float there for a little while, and then eventually the air conditioning system in here will take it away somewhere else. So I don't want to lose it, so I'm going to stick it on the table. I'll scoop out some peanut butter for my sandwich. I got to stick this somewhere, otherwise it just goes floating away too. But just for now, if it's just a few seconds like this, I can just leave it and let it float. I'll spread the peanut butter on my sandwich, onto the tortilla. And then I'll get my jelly ready. See, a lot of things you got to think about and manage while you're eating up here. And you just spread the jelly on the sandwich. That as well needs to get attached to the table. So there's my peanut butter and jelly tortilla or sandwich. From up here, I'll just kind of close it up and enjoy. See if you guys can enjoy it as it's coming to you.
An expedition on board the International Space Station doesn't just lead to advances in science. In some cases, it can cause changes to the scientists who work there. NASA astronaut Jessica Meir says being in space was even better than the dream she had about being an astronaut when she was a little girl, and that the feeling of looking down on the whole world of her previous experience took time to process.
In first grade, when we were asked to draw a picture of what we wanted to be when we grew up, and I remember drawing a picture of an astronaut standing on the surface of the moon, the kind of iconic Apollo image in the spacesuit next to the flag on the moon. And that was what I drew then and said I wanted to be an astronaut, and then always said it all the way through since that time. I knew that I was going to be ecstatic being in space. You know, it was my lifelong dream, and I knew that it was going to make me happy. But I didn't expect how incredible it felt. And I said that a lot to people, that it's even more incredible than I ever imagined. And I really meant it, because I had thought so much about it, and I knew it was going to be the most extraordinary experience of my life. But I wasn't even prepared for how I felt, the level of excitement and just pure joy that I felt all the time in that environment. I really felt like I was home. I felt like that was where I should be, and I don't think I stopped smiling for pretty much the entire 7 months. I would find myself thinking,
how can this be real, that I'm floating above the planet and looking down on it? Even after 7 months and, knowing what we had done to get there and that I'd really worked for this my entire life, it still is actually hard to convince yourself that it's really happening, which maybe sounds a bit funny, but even after 7 months, it just felt that way looking down on the Earth. Wow, this is real. I'm up here floating above the Earth. When you're in the space station in the cupola, there are stars all around you, and you can really feel it that way. I think that's a good way to describe it. You feel like it's more three-dimensional and diffuse, and you gaze off into it, and it is really just extraordinary to think about that scale, and then look back at the Earth and realize that we're just such a small component of that. This was really what had driven me since I was 5 years old, was what it was going to be like to have that feeling, to look back on the planet and you're not there. That's the place, the one place where everything has happened in your life. Everything has happened through the entire history of the human species. Everything you've done, all the places you've been, everything is down there in its entirety, and you're separate from that. It actually does feel different looking at Earth through your visor, just through your helmet visor, versus looking out of the window. I think the colors are even more vibrant, and I think also just mentally, psychologically realizing that, there's nothing between the vacuum of space except for this spacesuit and your visor. There's nothing, between you and it, and you're really out there in your own little mini spacecraft. It has the life support system, everything that you need to be kept alive, and it's just you. And you have this sense of just being by yourself in this environment with your own little life support system. And I love that feeling. I don't know what it is exactly about that, but I feel really kind of peaceful and relaxed in that. And in the spacesuit, you're looking down and seeing the Earth from above, from the outside, with your own human eyes. It changes you as a person. When you look back and you're in this blackness, devoid of any color, the blackness of space, and suddenly there's this brilliant blue glowing marble down there. It's so easy to see from up there that we're all in it together. You don't see those geopolitical boundaries, all of the man-made boundaries that we've imposed upon ourselves as humans. You don't see any of that from space, and you just feel this sense of commonality more, and something that unites us all, and just that we're all human.
If you'd like another look at any of these stories, navigate over to YouTube and Facebook. You'll find them all there, along with lots of other great features on a wide variety of NASA topics. Now, if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast. That's a weekly show that looks at all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan takes a close-up look at an International Space Station experiment that lets school kids shoot photos of Earth from space. Sally Ride EarthCam. Go to nasa.gov/podcasts for this week's episode and all the previous episodes. In fact, the full library of all the NASA podcasts are there, as well as on Apple Podcasts, Google Podcasts, and SoundCloud.